This video is brought to you by Sporlan, quality, integrity, and tradition.
This morning, I've got a walk-in freezer that is operating. It's colder than you know what in here. Ice cream's rock solid, but I had a service technician here yesterday and he had a blown fuse and the electrical disconnect on the roof and he couldn't find a reason for it to go bad. Now, this is the second time that fuse has blown in about a 2-month period. So I'm gonna try to dig into this a little bit deeper just because I wanna make sure that we're not missing anything. So we're gonna start on the roof. He was here yesterday, he got it working, it's doing good. It's not iced up or anything. There is a little bit of ice on the suction line, that's just poor insulation. So I'll jump up onto the roof. All right, here's my condensing unit. This is a 208 volt 3-phase system. The condensing unit powers the evaporator coil. We have got a Paragon digital defrost clock. And we are trying to figure out why we are intermittently blowing fuses. Something is going on here, and I'm hoping to get to the bottom of it. Now, I'm just doing visual inspections, just looking at the electrical down in here. Like, you know, it's certainly not amazing. Something that I would do in a test trying to figure out where the problem might be is just carefully kind of jiggle the wires, see if anything is intermittently rubbing out. Be careful, obviously. Okay. Conduit. Okay. Overall equipment, I mean, there's a bushing down there going into the disconnect. It's not the greatest looking, but it works. Condenser doesn't look too dirty. All right, we're looking okay, so let's get into this a little bit deeper. It just satisfied naturally on its own. I'm listening and always pay attention to how motors slow down. You know, if you see an abrupt stop, that can be an indication of a bearing failure within a motor. Now, this motor I replaced fairly recently. This one was working okay. I believe this one was making a squeaking sound or something. I don't know if I made a video about that. That was a couple months ago. But yeah, I've had 2 people out here on 2 different occasions within the last 2 months changing fuses, and they're the main fuses coming into the disconnect switch. So I like to watch natural operation. Just let it do its thing, okay? All sorts of things can cause fuses to go bad. Overcurrent, obviously direct shorts, that kind of stuff. So we're just monitoring. We wanted to see, you know, normal operation. Obviously they need new insulation, but that's not going to cause a fuse to go bad. Compressor doesn't show indications that it's been flooding back a lot. That can be things that can cause it to overload. Yeah, just not seeing anything jumping out at me. So we're going to have to dive into this guy. I've got my insulation tester. We're going to test this compressor. We're just going to go down to the evaporator coil too and go through that looking for broken wires. Oftentimes it'll be rubbed out wires in the evaporator coil will be the issues, but we're going to give it the big picture kind of a thing, right? So don't see any issues with the compressor's electrical connections. Looks okay, but we're going to pull those off and do an insulation test on this compressor. Now, understanding something, I've said it a million times, doing an insulation test should not necessarily be a one-stop, your compressor's bad. I mean, if it's reading really, really bad, then yeah, but most manufacturers, especially Copeland, recommends that insulation tests be a trending number. You know, you watch it over time and you watch the insulation degrade as you're doing routine maintenance tests. But in this situation, we're looking for something, you know, so I'm gonna go ahead and do a test. We'll pull the wires off and check that compressor. All right, we are going to switch to insulation test. This is a 208 volt system, so we're gonna be testing at 500 volts and we're gonna do a test. Greater than 550 mega ohms. Testing at 527 volts. Now, that tells us that the insulation in the compressor is in good shape, and more than likely the windings of the compressor are not causing our problem that's making the fuse blow. That's the idea here, okay? So we're testing the breakdown or the the potential breakdown of the insulation. You got to figure that the motor down in there, all the windings and everything are sitting in, you know, refrigeration oil partially, and the windings have a protective coating on them, so we're testing that protective coating. So it's not indicating that there's an issue with the compressor, so we can proceed further with our inspection of this unit. I put the compressor back together. I pulled out the time clock, did an inspection on that. Don't see any issues. It's dusty, but I really don't see anything in here. Looking in the disconnect switch, it looks like there's dielectric grease on the knives. That looks good. These are new fuses that we just put in, and we left 3 spares. We're gonna turn this on, slightly close that. Here we go. Oh, nope. Gotta do it like this. There we go. All right, the system is probably pumped down. There we go, we're running. Let's have a look at how the knives are making contact in there. They seem like they're engaging well. The disconnect doesn't look to be in bad shape. We'll double check the tightness of all the wires. But I mean, we look okay. Condenser fan motors are running. Let's get a current tester on there and test current on the unit. Currently running 11.5 amps on that circuit. 9, almost 10 amps on that circuit. And then let's do this last one. All right, so we've got 10 amps, 10 amps, 11.5 amps. Huh. I would expect that 2 of them would be the same and 1 of them would be lower, not 1 of them, because there is some single phase stuff on this equipment. So the fact that we're getting 11.5 amps on one line and then almost 10 on the other 2 is kind of odd to me. I'd normally see 11.5 on 2 and a single 10, because that would be the single phase stuff. But I guess it's possible that they have the single phase stuff balanced out. I don't know if any of that stuff makes sense to you guys, but my head thinks weird random crap. Let's start testing some voltages at this disconnect switch real quick. We're testing 3-phase power, line 1 to 2, 2 to 3, and 1 to 3. That's incoming, okay? And then outgoing, 211, 209, 211. Okay, so that's the same. There shouldn't be any voltage drop across this across this unit. Nothing. 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 No voltage drop. Let's get a thermal imaging camera and have a look at the disconnect to see if the fuses are getting hot, like they're not making a good connection or anything. All right, so we are looking at the disconnect, and I mean, I don't see any like major hot spots. All the fuses are warm, it seems. Everything seems pretty equal. Nothing seems to be overloaded per se. Just kind of, you got to be careful because as you move the camera around, it'll pick up other heat sources. But yeah, that looks fine. Don't see anything that's scaring me there. All right, this is an insulated screwdriver. Just double checking. Yeah, those are tight. Those are tight. Yeah, that one took about a quarter turn, but those look fine. Now this is the load side. This is not energized. Those are tight. We're just checking anything we can. Took a little bit of a turn. But I mean, just checking tightness of the things. Everything seems fine. Don't see any issues in the disconnect switch. We'll double check the contactor. Then we need to go down and do an inspection on the evaporator coil. Always want to look at how the wires are terminated. See, these ones are kind of getting pinched. The insulation is. So we need to pull those out a little bit so that way the insulation is not getting pinched. Come down to the bottom of this guy and there's a flyaway. Flyaways can be a problem. So this guy was in there, but there was a flyaway hanging out. Now I didn't see anything, and that's just when the wire's hanging out. I didn't see anything where it could have been touching, but you always want to watch out for those flyaways because they can cause intermittent issues there. So you want to make sure that the wire, you twist it, then torque down on it with the whole wire twisted in there. Look at that one. That's how that was in there. That's horrible. Lots of different things. But again, I don't see anything that it was touching. That's the middle one. There's nothing back there for it to arc against, but you got to make sure you get those wires all the way in there, because that's going to cause high current on only a, well, it's technically still going to make connection, but yeah, it still can cause problems. Always open up the contactors. Now this contactor is massively oversized for this equipment, but always open them up and inspect the points, because that can be an indication of short cycling, rapid on-off cycles. This one's a fairly new contactor. The other thing is when you put these things in, put the covers right side up. Aggravates my OCD, makes me go crazy. Looks like I gotta trim this right here. But yeah, get those contactors in there right side up so that way people can read all the information off of them. Fix that, cover flipped over right side up. Just kind of visually inspecting things. I went into the pressure control, don't see any issues in there. I'm not a huge fan of how they taped up this hole, but I don't see any rub outs. I inspected the wires. That's something I want to fix, but that's not what I'm going to fix right now. Just looking at these, I mean, I'm not seeing anything. There's no water in the bottom of the unit. This is interesting. Like I said, I think we're good up here. I'm just going to get some motor currents, and then we'll go downstairs to the evaporator and have a look down there. Alright, this condenser fan motor is running 0.53 amps. This one's running 0.49. The crankcase heater is running 0.15. The compressor's a little interesting because I've got 8.3, 8.3, 9.0. It's a little odd. Oh, but you know what? Remember, one of those legs is higher, so that's why. We've got lower voltage slightly, and so one of them's, yeah, I bet you that's it. I'm not seeing any problems up here. Those condenser fan motors don't seem to be overamping. We're going in the right direction. The condenser's clean. We don't seem to be flooding back. Seems to be good there. Don't see any rub outs anywhere. None of that. So we're gonna go downstairs and have a look at the evaporator now. I've seen it running in refrigeration mode, right? We walked up, the evaporator fan motors were running, so we know that works. Let's go ahead and put it into defrost. It should be pumping down now. Pressure control should cut it out here in just a second. And we know we've seen that already too. Okay, so we are in defrost mode now, so I need to go downstairs and I want to see the heaters operating within the coil. When you pull the cover off, look for spots where maybe it's shorted against the cover, because there is a mess of wires in these things. I don't see anything, so we're going to get in here with my current tester. Although those terminals do look pretty corroded, that is one thing to consider. Maybe the thermal imaging camera looking at this would be a good idea too, to see if we have any loose terminals. But I'm going to test all the heaters first to make sure they're all working, which we know they are because it's not iced up. But we just want to make sure. Places to look would be where the wires run on the bottom, where they get close to the heaters. Sometimes they'll rub out against the heaters and melt. So we're going to inspect all that, and then eventually we'll pull the fan guards off and have a look at the motor wiring too. Alright, so we're looking at the wires. Definitely a hot spot back there. We got to figure out what that is. But as far as the electrical connections go, I mean, I'm not seeing anything too crazy. Oh, the hot spot you're seeing is just the heater. This, yeah, one of these wires is pretty warm. That's going to be a heater wire. Okay, so we look back here. Oh, check it out, you can see all the heaters. So there's that one working, I think all the heaters are working. How many heaters do we have? 1, 2, 3, 4. I think there's either 3 or 4. And it looks like they're all working. So that's a pretty good indication. Okay, looking at the rest of the coil, those are just the motors back behind it. You're seeing the heat coming off from the defrost heaters. Let's look at the drain line heater. Do we have, is the heat trace working? There's a heat trace. I think it is working. Let's pull this back. Oh yeah, you can see the heat trace is warm. It's just a wire run on the bottom of the drain line, so that's nice and good. Don't have any issues with that. I'll get the insulation put back in a minute. And the thermal imaging camera can tell you a lot, actually. It's pretty cool. Well, this one's a pain because I was going to get in here and do an insulation test, but these are ECM motors, so you don't end up ruining the circuit board on those. Notice though, like how the brackets are rusted out. They ice this box up a lot. There's a lot of moisture in here, and I can show you something that indicates that they're not using this correctly. Look right here. They have a flour station where they bread stuff in here, and you can tell they've been doing it inside the freezer. So that means they open and close the door to bread something. You can't do that. That's a bit silly. Yeah, I am not seeing, there's no way to really test these motors. I've seen these break right here, so just kind of grab these connections, make sure they're not broken. There's no rub outs. I moved this, so I'll plug that back in. There's nowhere that it's touching the heaters or anything. All right, inspected all of these, pulled off all the blades, looked in there, nothing crazy, no broken wire connections. Coming over here, it's kind of a mess, but I inspected, it doesn't look like the wire's rubbed out anywhere. I opened up the temp control. It's rusty in there. It's definitely beat down. I mean, where do you start, you know? Rusted out temp control, maybe. Rusted out terminal board, maybe. I mean, there's so many different variables here. One thing I just thought of right now is there's a heat trace or a heater ran around this drain line, right? And it looks like it's going that way. Sometimes people don't use the proper end kit to terminate the end of that heater. So let's have a look at that. That was just something I was thinking of. Usually go to the end. It's running into the other box. It's not there. Let's look on the other side. It's running into the other box. We also need to open this guy up. See what's going on in there. Now, so one heater comes from this coil and goes over. What is this? Oh, look at that. That's the end of a heater from another coil. Okay, so this heater is running this way and going into that box. This heater over here is coming from somewhere else. So we need to go into the other box and look at the heater and make sure it's not damaged on the end. This is another walk-in, and the heater is terminating right here. I don't see any damage, but they definitely don't have the right connection kit on there. But they've just got wire nuts. So I don't see any damage there, so I don't think that's the problem. Let's go look at that electrical box like on this one. See how this one's got drips in it? Let's open up the other one. That doesn't look good. Looks like it's been flooding with water because it's all frozen right here. Up into there, there's a bunch of ice in the bottom, but it's not up to the switch. But you can see where it's flooded at one point because look at the water line on the switch. So it has filled up with water. Interesting. All right, so you can definitely see that that switch has been getting wet, but I don't see that as being our problem now because the fuse was blown yesterday and it's not, you could just see remnants of water in there, but this wire in here is probably full of water too. It's probably all ice in there. It's not completely full, but there's definitely a lot of ice in the conduit. But I don't see, I mean, where do you start with this? Like, I don't know if it's really worth all this because we still don't know if there's a problem in the unit. This is one of those things where we're gonna have to leave it up to the customer. And knowing this customer, They're gonna want to just change this equipment because of how old it is. They're very proactive about that stuff. I'm putting the box back together. I did not change anything. I'm gonna give the customer all my findings and let them make the decisions. But I did put a new gasket on here. Had one in my truck. What I'm gonna do is I'm gonna talk to them about replacing this equipment. So judging, and again, I'll give them options. I'll give them repair options versus replace options, but they buy their own equipment, so I guarantee they're gonna go with replacement. When they replace the equipment, the new evaporator they're gonna send is more than likely gonna be a Heatcraft Intelligent evaporator, and it's gonna require a dedicated power source. The old one is controlled by the condensing unit, but on the Intelligent, you can't do that. So they'll have to do a home run connection from the breaker panel. And when they do that, I will correct this where we're not coming out the bottom of the box. We'll come out the side or the top or something like that. That way there's no chance of the conduit filling up with water. We may even, well, we'll see. We'll figure that out. But I want to replace all these wires in here because I know they're all full of ice and I bet you there's some damage, but I'm not going to get too involved in that today because of how many other things I know that are wrong with this system. So I thought about it, and I'm going to go ahead and do an insulation test on the strip heaters, the defrost heaters. The problem is I don't know what the insulation rating should be on these, so I'm just going to write down all the numbers and compare them. Two of the heaters are the same, and then the other heaters are the same too, so, well, similar. That's interesting. Yeah, I don't know the expected resistance value though, but so far we got 186 on the drain pan heater. Ooh, that one's really low. But again, I've hit the point where there's two heaters in the top of the coil that are very similar. So no, we're gonna call it at 130. So I'll mark it down. I'm just writing them right here. Okay, let's try again. This one's really low. So there's four heaters: drain pan heater, bottom coil heater, middle heater, and top heater. And look at the two bottom ones are similar, and then usually these two they should be identical. This one's testing really low, but all of them have lower than what I'd expect. I wouldn't go with just changing one heater. Again, there's just a whole list. Look at the board. What's going on behind that board? Now it's insulated, so it shouldn't be making any kind of a direct connection to the backside, but look at, I mean, just the corrosion. The motors are rusted and they all have weep holes in them. I don't know if they have moisture, but you can clearly see the fan brackets are about to break because of how rusted they are. The temperature controller wiring's a mess over there. That temp control's full of rust. The electrical box over here is full of water and the conduit's full of rust. Again, I think they're going to replace this equipment, but I'm just doing my due diligence, just going through everything. So I'm going to wire the heaters back into the circuit. All right, I came back up onto the roof and turned the system on, and it came into refrigeration mode. So I immediately let it run for about a minute, then I put it into defrost, because what I wanted to make sure was that by doing the insulation test on those heaters, I didn't damage them further, if they are damaged at all. What I'm going to do is I'm going to put everything together. I'm going to give Heatcraft Refrigeration's tech support line a call and ask them if they have any insulation values, mega ohm values for those resistance heaters. I don't think they're going to, but I'll give it a shot. And at this point, I'm just going to give the customer a list of issues and let them know, hey, this equipment is, what does the serial number say? It's a 2015, so it's not quite 10 years old, but we'll give them a list of issues and see where they want to go with it, if they want us to start tackling out the known things. So at a minimum, I would change the circuit board, not even a circuit board, it's more or less a terminal board. The terminal board for all the wire connections. I would strongly suggest that they let me go ahead and change the evaporator fan motors. Again, there's nothing wrong with them, but there's no way to really test those ECM motors. And I do see a lot of moisture, like rust kind of looking stuff coming out the bottom of the motors, so I don't know how much moisture's gotten inside of them. I would suggest that they probably let me go ahead and change the fan brackets because of how rusted they are. They're gonna break soon. And possibly the defrost heaters. It just depends, you know? So we'll see where they want to go with that. Other than that, I'm going to put this unit together, and I can't really say too much more until they make a decision on where they want to go. You know, sometimes these things can be difficult to troubleshoot. Oh, another thing too, I'd like to repair that electrical connection right there where there's no chase nipple on the defrost clock, and then also want to change that electrical box inside the freezer. But I'm telling you, these guys, they would rather just put in new equipment and get a warranty with it. We'll have to have an electrician redo the electrical inside the box, and you know, we'd eliminate a lot of our issues if they did that. But we'll see. Again, it's their decision. I just give them my diagnoses and they kind of decide where they want to go. One last thing I want to address too is I don't see the need to put service gauges on this equipment, but I'm using my judgment and some vital signs. I got here early this morning. Judging by the temperature inside the box and the temperature outside and the condition of the equipment coming up, didn't really look like it was flooding back to the compressor. You can have some weird situations if you're having flood back. That can cause high current when the compressor starts up. Different stuff like that. I don't think that's a problem. Plus, this is a pump down system. I did have a service technician here yesterday, and he did put his service gauges on there and told me what the pressures were and the saturation temperatures. And judging by what he did yesterday, again, I don't see a need to put gauges on this. I think this is purely an electrical failure. Where the problem's at, I don't know, but yeah, it's got to be somewhere in the electrical system. After, you know, watching the box and listening, I would like to say too that one of these two fan motors sounds like it has a bearing issue. I don't hear it from this one. It might be hard for the camera to pick up. But yeah, so we'll talk to the customer. There's a lot going on here.
Sometimes trying to figure out where the electrical problem is can be a big, difficult problem, right? You know, trying to trace down these issues can be a headache. Now, this particular piece of equipment or system has a lot of issues. Now, they're all minor issues, and there's a few of them that certainly could cause a fuse to blow. But which one is it? You know? And there's a lot of variables in here. Like simply seeing how they have the breading station inside the walk-in freezer means that the customer is regularly opening the doors to dip something in some sort of a batter, right? Or to bread it so that way they can make a batter. And, you know, that's not the proper way to use a walk-in freezer. They shouldn't be opening that door and using it as a reach-in cooler, right? The rust on the evaporator, you know, indicates that there's a lot of moisture, which would make sense with them opening and closing the doors to use that batter or the dry mix for the batter, you know. There's so many different variables. Finding that electrical switch inside the walk-in freezer box itself that you can clearly tell had filled up with water at some point. I mean, there's so many variables, right? But I did everything I could to make sure that, you know, it was nothing super obvious, and, you know, and then I gave the customer the information. Now, it has since been, I'd say, about, I'm actually looking at my footage. It's been about a month since I was last there. We haven't had any other issues since. Okay, so that's a good sign. But the customer did actually opt to go ahead and replace the equipment. Now, I have not received it yet. They purchase it themselves, and then they just ship it to me, and then I'll install it and go through all that. But that'll be a whole process because we're going to have to get an electrician involved, and it's a whole thing. But, hey, everything is working as best as, you know, as it could, I guess. while I was there, and, I left the system operational. We don't always have home runs with these. They're not always perfect, We just got to kind of do our best, right? We're looking for an obvious sign. Now, in this situation, I'd have 2 technicians previous within like a month of each other come out and change the fuses. Each one couldn't find anything wrong. And I shouldn't say couldn't find anything wrong. Like, they told me, like, hey, the evaporator's rusty. Hey, there's weird stuff here and there. But I just kind of wanted to see it with my own eyes before we basically condemned this equipment. So I came out there and I kind of validated what they saw and then found a little bit more. I extensively tested the insulation values of the compressor and of the strip heaters. I don't like them. Okay, I don't like the insulation readings of the strip heaters. The compressor, I did kind of address it, and I wanted to point it out too. I did kind of address it. The fact that when I checked voltage to the system and we had one leg that had higher voltage than the other 2 legs is probably why I saw higher current on one leg than on the other 2 legs, right? Because normally I said with 3-phase equipment, if it was a normal 3-phase system, you should have pretty equal current draw on all 3 legs, right? But this particular piece of equipment has single-phase condenser fan motors, single-phase evaporator fan motors. So it's inevitable that 2 of the legs, assuming that the voltage is equal on all 3 legs, 2 of the legs would have a higher current when the system is operating, because the single phase motors are only going to pull from 2 legs of the 3-phase power. So you would typically see a higher current reading on 2 of the legs and not on the 3rd leg. But in this situation, we were seeing a higher current reading on 1 of the legs and not the other 2. It's still a little bizarre, because even accounting with the voltage discrepancy, it still kind of baffles me as to why they're seeing a higher current. But it's not a huge deal. It's just something that I observed, and I'm probably spending a little more time even thinking about it than I need to, right? Hey, I really appreciate you guys making it to the end of the video. As I always say, it's so awesome. Thank you so very much. Be sure, if you haven't already, check out my website, hvacrvideos.com. Look at the show notes of this video. There's a couple different links on different ways if you want to help support the channel. Thank you so much to all of you that have continued to support the channel in all the different methods that you do so, okay? Even if it's simply as just watching the videos, that is a great way to support the channel. So thank you so very much. But then there's other ways too. Again, look in the show notes. There's links to all different methods. I really do appreciate you guys. Thank you so very much. And we will catch you on the next one, okay?